So, in this chapter, I will discuss to you all about chemical reactions, such as how they occur, and how a certain substance, such as elements or compounds, are changed into other substances. I will also discuss to you about chemical equilibrium and how to write a balanced chemical equation. So, first, what is chemical equation? So, basically, we represent chemical reactions using chemical equations. Taken for example, the certain chemical process. So, when a hydrogen gas burns, for example, it reacts with oxygen in the air to form water. And we write the chemical equation for this reaction as something like this. So, what we basically do is uh, we just have to write the certain element or compound on the left side, and then you do the same on the right side, and then we join the two by putting an arrow between them, and the stuff on the left side are called the reactant, and on the right side we call it the product. So in this particular reaction, for example, you can see that two individual molecule of hydrogen gas, which is H2, can combine with a single molecule of oxygen gas, which has the formula of O2, to make two individual molecules of water, which is H2O. Now, if you count the number of atoms in this example, you will notice that there are four atoms of hydrogen on both sides of the chemical equation. And there are also two atoms of oxygen um, on both the left and the right side of the equation. Now, this arrow between the compounds or elements are often referred to as yield. So for the certain example, you can read it as two molecule of H2 reacts with one molecule of O2 yields two molecules of H2O. So to explain further or to be more concise, let me explain in this manner. So as you can see, this number here, which are called coefficients, indicates that there are two individual H2 molecules and one individual O2 molecules and two individual H2O molecules. Also, I want to specify that this italized letter, besides the reactants and the products, are what we call the physical state of each of these individual substances. So we have S is the abbreviation for solid, L is for liquid, G is for gas, and AQ is what we call aqueous, which means dissolved in water. So what this means is that the condition used for this particular reaction involves reacting two molecules of gaseous, that is H2 gas, with one molecule of O2 gas to yield or to produce two molecules of each H2O, which is liquid. Okay, so let us now move forward. So now there are three different kind of chemical reaction, that is combination reaction, decomposition reaction, and combustion reaction. So in combination reaction, two or more elements or compounds are combined to form one or more product. So here's an example. As you can see on the left side of the equation, there are two different substances, and on the right side of the equation, there is only one. So this is a combination reaction, since what's happening is that the two different reactants are combining to form one product. So here's another example. So as you can notice, there are two or more different substances on the left side of the equation, or two or more reactant, and then they are combining to form one single product. So same with this last one, there are two different substances on the left side of the equation or the reactant, and then you combine it to form one product. So basically, if you see two or more reactant on the left side of the equation and only one product on the right side of the equation, it is what we call a combination reaction. Okay, so the second one is the decomposition reaction. So decomposition reaction is basically the opposite to a certain degree into composition reaction. So in decomposition reaction, one substance undergoes a reaction to produce two or more substances. So taken for example, in contrast with combination reactions, what we see here in a decomposition reaction is that only one substance or reactant on the left side of the equation and then two or more substances on the right side of the equation. So, second for example is the decomposition of potassium chlorate into KCl and O3, or this decomposition of this PbCO3, which is lead chlorate, into PbO and carbon dioxide, and same with the last one. So you can see that, again class, there is only one substance on the left side of the reactant, and there are two or more on the right hand side or the product side of the equation. So we call this certain reaction a decomposing reaction, because what's happening is that the reactant is decomposing into forming two or more product. Okay, so the last type of reaction is what we call the combustion reaction. So combustion reactions are rapid reaction that produce a flame. So basically, combustion reactions is a rapid chemical reaction in which hydrocarbons or an alcohol reacts with oxygen to make carbon dioxide and water. Okay, so example, this molecule right here called ethanol can combine with oxygen in a combustion reaction to form carbon dioxide and water. Once again, I want you to note that the coefficient between each of the reactants and the products are 1, 3, 2, and 3 respectively. Another example, this molecule right here can combine to 2 to 19 ratio with oxygen and gas in a combustion reaction to form carbon dioxide and water. Now let us go to balancing chemical equations. So before we can really use chemical equations, we have to first balance them. And we do this by adding coefficients in front of each formula in the equation until the total number of each atom in the equation is equal on the both sides of the equation. Also, I want you to note that you cannot change the subscript of the molecule, for that is what makes the identity of the molecule. If you change that, then that will become a different molecule. So as an example, consider burning a propane gas. So by experiment, you determine that propane reacts with oxygen in air to give carbon dioxide and water. You also determine from the experiment that the formulas of propane, oxygen, and carbon dioxide and water are this one. We have C3H8, O2, CO2, and H2O respectively. So you can write a chemical equation of which is this one. So this equation is not balanced because the coefficient that give the relative number of molecule involved have not yet been determined. So to balance the equation, you have to select coefficient that will make the numbers of atoms of each element equal on the both sides of the equation. So because this, as you can see, because there are 3 carbon atoms on the left side of the equation, which is this one, C3H8, you must have 3 carbons atom on the right side too. So to achieve this one, you write 3 for the coefficient of CO2. Now we just, in this example, we just specify this one, this coefficient number 1 in C3H8 to show that it is determined. But normally, when the coefficient is 1, it is omitted. So similarly, there are 8 hydrogen atoms on the left side in C3H8. So you can also write 4 for the coefficient of H2O. Now the coefficient on the right are not determined, and there are 10 oxygen atoms on this side of the equation. So 6 from the 3 CO2 molecules and 4 from 4 H2O molecules. You you can now write 5 for the coefficient of O2, and we also drop the coefficient 1 from the C3H8 to have a balanced equation, which is this one. It is also a good idea to check on your work by counting the numbers of atoms of each element on the left side and then on the right side of the equation. So this method that I have shown to you is what we call balancing by inspection. It is essentially a trial and error method. So, okay, let's now have another example for balancing equation. So we have here, letter A, we have H3PO3, or we call that as phosphorus acid, into H3PO4, or phosphoric acid, plus phosphine. Another one is we have calcium plus water is equal to calcium hydroxide plus H2. So first is we look at the chemical equation for atoms of element that occur in only one substance on each side of the equation. So you begin balancing by the equation in one of this atom. So you use the number of atoms on the left side of the arrow as the coefficient of the substance containing that element on the right side, or vice versa. So after balancing one element in an equation, the rest will become easier. So let's have a solution for letter A. So since we are doing a trial and error method, it is therefore easiest to balance first the oxygen atom. So to do this, you note that H3PO3 has 3 oxygen atoms, and you can use 3 as the coefficient in H3PO4 on the right side of the equation. Now there are also 4 oxygen atom in H3PO4 on the right side. So you can also use 4 as the coefficient of H3PO3 on the left side of the equation. Now, as you can notice, this equation is now balanced in terms of its P atom and H atom. So, you can write the balance equation in this form. And as you count the number of atoms in both sides of the equation, you can now determine that it is balanced. Okay, so let's go now to solution letter B. So as you can see, the calcium atom in this particular example is already balanced. So as it is already balanced, you can now move forward into balancing the other atom in this example. So let us now take a look on the oxygen atom. So you can notice that there are 2 oxygen atoms on the product side, or the right side of the equation, and only 1 oxygen atom on the left side. So you can simply put 2 as the coefficient of water to balance the oxygen atom in this particular example. And by doing so, you will also notice that the hydrogen atoms are already now balanced. So you can write the balance equation in this manner. Okay, so let's move to formula and molecular weights. So chemical formulas and chemical equations both have quantitative significance in the subscript of the formula and in the coefficient of the equation. So similarly, the coefficients in a balanced chemical equation indicate the relative quantities of reactants and the products. But how do we relate the number of atoms or molecule to the amounts we measure in the laboratory? So since it is not possible to count individual atoms or molecule, we can indirectly determine their numbers if we know their masses. So if we are to calculate amount of reactants needed to obtain a given amount of product or otherwise extrapolate quantitative information from a chemical equation or formula, we need to know more about the masses and the masses of atoms and the molecules. Okay, so formula and molecular masses. So the molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of a substance. It is therefore the average mass of a molecule of that substance expressed in atomic mass unit or AMU. For example, the molecular mass of water, H2O, is 18 AMU. You have 2 times 1 AMU from 2 hydrogen atoms plus 16 AMU from 1 oxygen atom. Okay. So formula mass. Formula mass of a substance is the sum of the masses of all atoms in a formula unit of a compound, whether molecular or not. So for example, is sodium chloride. Sodium chloride has a formula unit of NaCl and has a formula mass of 58.44 AMU. So you have 22.99 AMU from sodium plus 35.45 AMU from chloride. So NaCl is ionic. So strictly speaking, the expression molecular mass of NaCl has no meaning. So on the other hand, the molecular mass and the formula mass calculated from the molecular formula of a substance are identical. Okay, so let's have an example for you to understand clearly. So we have this calculating the formula mass from a formula. So example is that you calculate the formula mass of each of the following three significant figures. Okay, so A we have chloroform, and then B we have iron sulfate. So what do? So first, we identify the number and the type of atoms in the chemical formula, and then you use the periodic table to obtain the atomic mass of each of the elements present in the compound. You also have to take into account the number of each atom present in the formula, and then you sum the masses. So if the atoms in the formula are enclosed with parentheses, just like in letter B, the number of each element within the parentheses should be multiplied by the subscript that follows the final or closing parenthesis. Okay, so this is how you do it. Letter A, so this is the calculation. You have one carbon atom, and then you also have one hydrogen atom, and then you also have 3 chlorine atoms. So you have 1 times atomic mass of carbon, which is 12, and then you have 1 times atomic mass of hydrogen, which is 1, and then since you have 3 chlorine atoms, then you multiply the atomic mass of chlorine, which is 35.45, times 3, then you'll have 106.4 AMU, and then you sum all of that and you'll be having 119.4 AMU. However, it was determined that we should round it to at least three significant figures. So you will have a final answer of 119 AMU. Okay, so this is how you do the calculation for iron sulfate. So first is you identify the number of each atom. So for iron, you have 2. And then since SO4 is indicated by a parenthesis, you simply multiply the subscript. And then you will be having the number of sulfur 3. And for the number of oxygen atom, you'll have 12. And then you simply multiply the number of atom times each atomic weight. So you have, for iron, you have 2 times 55.8. For sulfur atom, you'll have 3 times 32.1. For oxygen atom, you'll have 12 times 16 AMU. So you simply add all of the atomic weights, and then you will be having a formula weight of iron sulfate, which is 399.1. And then you round it to three significant figures, and you will be having 4.00 times 10 to the 2 AMU. Okay, so let's go over the Avogadro's number and the concept of mole. So when we prepare a compound industrially or even study a reaction in the laboratory, we deal with tremendous number of molecules or ions. So chemists have adopted the mole concept as a convenient way to deal with the enormous number of molecules or ions in the samples that they work with. So a mole, which has the symbol of MOL or mole, is defined as the quantity of a given substance that contains as many molecules or formula units as the number of atoms. For example, one molecule or 1 mole of ethanol contains the same number of ethanol molecules as there is in a 12-gram carbon atom of carbon 12. So the number of atoms in a 12-gram sample of carbon 12 is what we call the Avogadro's number, to which we give a symbol of Na. So recent measurement of this number gives us the value of 6.0221367 times 10 to the 23, which to three significant figure is 6.022 times 10 to the 23. Okay, so a mole of a substance contains Avogadro's number of molecules or formula units, or the 6.02 times 10 to the 23. So the term mole, like a dozen or a gross, refers to a particular number of things. So for example, when you say a dozen of eggs, it is equals to 12 eggs. So when you say a gross of pencils, it is also equals to 144 pencils. So therefore, when you say a mole of ethanol, it is also equals to 6.02 times 10 to the 23 ethanol molecules. So in using the term mole for ionic substances, we mean the number of formula units of the substance. So for example, a mole of sodium carbonate or Na2CO3. So a mole of sodium carbonate is a quantity containing the Avogadro's number, or 6.02 times 10 to the 23 units, sodium carbonate units. But each of this unit of sodium carbonate contains 2 sodium ions and 1 carbonate ion. So therefore, when you say a mole of sodium carbonate, it also contains 2 times 6.02 times 10 to the 23 sodium ions and 1 times 6.02 to the 6.02 times 10 to the 23 carbonate ions. So when using the term mole, it is important to specify the formula of the unit to avoid any misunderstanding. So for example, a mole of oxygen atom with the formula of O contains 6.02 times 10 to the 23 oxygen atom. So a mole of oxygen molecules with the formula of O2 contains 6.02 times 10 to the 23 oxygen molecules. That is 2 times 6.02 times 10 to the 23 oxygen atoms. Okay? So the molar mass of a substance is the mass of 1 mole of a substance. So carbon 12 has a molar mass of exactly 12 grams per mole by definition. So ethanol also, whose formula is C2H6O, or we use this normally on, we condense this in a structural formula, C2H5OH, has a molecular mass of 46.1 AMU and a molar mass of 46.1 grams per mole. So I want you to note that for all the substances, the molar mass in grams per mole is numerically equal to the formula mass in an atomic mass unit. Okay, so let's have this as an example. So, calculating the mass of an atom or molecule. So, letter A, question is, what is the mass in grams of a chlorine atom or Cl? And letter B, we have, what is the mass in grams of a hydrogen chloride molecule or HCl? So in order for us to solve this type of problem, we need to consider using molar mass and the relationship between the number of atoms or molecules and the molar mass. So for letter A, this is the solution. So the atomic mass of chloride atom is 35.5 AMU. So the molar mass also of the chlorine atom is 35.5 grams per mole. Now we divide that, or dividing 35.5 grams, which is per mole, by 6.02 times 10 to the 23, of which is our Avogadro's number, of which is, I want to specify that this Avogadro's number is unitless. So it gives us the mass of one atom. So as for this one, for letter A, the mass of a chlorine atom is simply 35.5 grams divided by 6.02 times 10 to the 23, in which you will have 5.90 times 10 to the negative 23 grams. Okay? So let's proceed to letter B. So this is the solution. You have the molecular mass of hydrogen chloride, which is equals to the atomic mass of hydrogen plus the atomic mass of the chlorine, which is, we have 36.5 AMU. So therefore, 1 mole of hydrogen chloride contains 36.5 grams HCl, and that the mass of an HCl molecules is simply 36.5 grams divided by the Avogadro's number, which is 6.02 times 10 to the 23. Then you will be having 6.06 times 10 to the negative 23 grams. So also, I want you to know that an individual atom and molecules are incredibly small, or gamay kay siya. So therefore, whenever you are asked to calculate the mass of a few atoms or a molecules, then dapat mag-expect ka nga gamay kaayo ang iyang mass. Okay, so that's it. I guess that ends our lesson up to this topic only for now. Since The next topic I will be discussing about they call this mole calculation, and I guess lisod kay siya kung through this lang. So let's have a class on Wednesday. You also prepare calculators, and that's it for our class for today. So also I will be giving in the last part of this slide, I will be also giving exercises, and you submit that before Wednesday or before our next class. So that would be until Tuesday 11:59 a.m. Okay. So that's it, and have a good day.